Hello, everybody. Thank you so much for joining us today. Our today's webinar is on the topic Kubernetes Stateful Availability and Recoverability, which will be presented by Rashid Amir, who is the CEO of Stakater, and Anthony, who is a cloud native architect at Portworx. So we'll also have a 15-minute question and answer session at the end of the webinar. So if you have any questions, please. We are just going to wait for a couple of minutes so more participants can join us. And thank you so much for joining us. And I hope you all have.
Hello.
Hello, nice to see you.
Very good. Welcome, everyone. Thank you for joining us on this this Wednesday morning afternoon. We're just between those two times a day in these time zones. So let's get started. We're a few minutes in now, and anyone coming in late could probably catch up on a catch up of this also. So some introductions. Do you want to introduce yourself, Rashid?
Yeah, sure, I can do it. Hi guys, I'm Rashid. I'm based in Sweden, Stockholm. We have quite nice weather today. Not very warm and not either very cold as well. But it's not like a typical summer in Sweden. But yeah, it's okay. And so guys, I'm CEO and co-founder of Stakater, a hardcore techie. Been a Kubernetes fan for like since its inception, and been helping customers, on their journey to adopt Kubernetes, like be it from the a strategy perspective or development and operations, and how to do all sort of stuff around Kubernetes, because it's not just Kubernetes. There's a lot of like tools and ecosystem around that that is required, to get it running, And then today's topic is also one of those like backup and disaster recovery. That's very key, one of the key aspects. Yeah, so that's about me. Over to you, Anthony. You can introduce yourself here.
Thanks, Rashid. Yes, so I'm Anthony. Maybe I'm less of a hardcore techie. Well, I trained as a software engineer some time ago now, as the grey hair will tell you. And I've spent my career in managed hosting, bit of financial technical software, learned to be very careful what I typed into computer systems. I spent time in the DevOps software world and a lot of time in managed AWS, so architecture on that. Have a problem-solving brain, I hope. Sometimes you get stuck, but it's a great technology area that we're living in, this time we're living in. I feel very grateful to be part of this technology era that is changing the world. So very happy with that. And I work for Portworx. Portworx was purchased by Pure Storage about 2.5 years ago. And this gives us the ability to do cloud native storage, which I'm going to talk about a little bit today. But what's special about today is we've got Rashid, who's a practitioner, a techie, an entrepreneur, and able to share his experience with his customers, providing solutions to the challenges that you and they faced, and we can learn from his experience. So that's today's purpose. But who is Stakater?
Yeah, so I can introduce, guys. So we started like in 2016, based in Sweden, as I mentioned before, but now we are quite global. Like we have team in Czech Republic, in Pakistan, India, Australia, and Netherlands. So we're quite global in that sense with team members. But we are all like laser focused on I think helping customers in adopting Kubernetes. And we are an engineering organization. So everyone is like, most of the team members are like have a developer background, but are really passionate about, doing looking into Kubernetes and how we can extend Kubernetes as a platform to help customers build solutions on top of Kubernetes. So we just help customers either run Kubernetes or help customers bring workload on top of Kubernetes. And we work with different distributions of Kubernetes, not just the vanilla Kubernetes, but also I've been working with enterprise distributions like the OpenShift, and also like been looking into Tanzu, Rancher, and of course all of these what you call XKS, like Kubernetes on the cloud. So when we started doing Kubernetes, it was way back. There was no managed Kubernetes offering from Amazon and Azure. And I still remember our first cluster that we set up on Amazon. And we had a hard time, doing an etcd high availability because it's way 2017. There was no managed Kubernetes, so you had to use open source like available installers and fix everything around that. And there was no stateful sets by then. No one was thinking of running stateful applications on Kubernetes at that time. So everyone was like just stateless applications. But now, fast forward, I think the things have changed and things have improved a lot. And now we're doing both stateful and stateless applications of Kubernetes. So yeah, so that's about it. As and if you can go to the next page, Anthony, I can quickly, you can glide it over actually, because it's gonna be animation. So yeah, so I think we as a company, we offer like customers like services both in consulting side and also in managed services, where we are helping around everything around Kubernetes. So we can manage it for them, not just Kubernetes, but the ecosystem and also support around it. And then we also help customers with jump starts of Kubernetes if they want to do a jump start, or if they already have a Kubernetes platform and if they need help with assessment, we also do that. But everything, core DNA is Kubernetes and its ecosystem. And then partnering up with leading companies in the world who are building solutions around Kubernetes, so that we can assist customers in picking up the right technology or solution based on their needs. So yeah, that's about Stakater. So I think over to you, Anthony. You can do the Portworx. Yeah.
Thanks, Rashid. So Portworx, as I said, bought by Pure Storage. What do we solve, right? So we solve the problem of doing persistence in Kubernetes, right? So it used to be crazy talk to bring state into Kubernetes, and we'll talk about why that's no longer the case. But essentially, when you write some data, you want it to stay where it is, and in case that fails, then you want it to be available wherever it is after that, right? Self-healing and so on. So this foundational storage we have has been built out to include solutions that are what I would call non-functional requirements, right? That means that you can meet your goals of availability and things like that. So we provide disaster recovery, we provide high availability, we provide encryption at the foundation. And then on top of this, we built solutions around backup because we understand Kubernetes, we understand how to back things up in Kubernetes, in an app consistent way. And then we realized that people who are running services, data services in Kubernetes itself, they don't necessarily want to understand how to set up a Galera cluster in Postgres. They probably just want to consume data service in the same way as they did in public cloud, right? Which made public cloud sticky, which caused shadow IT and all these things. They want to be able to do that wherever they're operating their workloads. And through a database as a service that can go into your clusters wherever they are, we bring that ability as well. That's a recent addition. Last year and a half, we brought that in. But these are the sort of core areas that we operate in. And who do we operate these things for? Well, all sorts of industries, all sorts of customers, from telcos. I've got a rogue headset, apologies. From telcos to banking customers, multi-tenancy cloud in KPN, for example, RBC, we'll talk about later. Roblox, massive scale for keeping the kids quiet in COVID and beyond, right? So they use Portworx as well. And CHG Healthcare, when it comes to really compliant systems, so HIPAA and that sort of thing, we can help them with their solutions as well. So that's a high level of what Portworx is. We're here today to work out how to do stateful apps in Kubernetes and what those apps need. So a definition of what a stateful app is would be helpful, right? So stateless apps, Nginx, for example, right, it just passes something through. But what I'm finding is that we have stateless apps like Nginx. What we're finding is stateless apps are being instrumented for the benefit of the people who are running them, right? So you get more insight. So even things that are natively stateful, like video conferencing, right? That used to be stateless, is now becoming stateful because it's beneficial to the people who run it. And that is because the wisdom they can get from that data is now very valuable, right? Data is the new oil, as they say. So things are becoming more stateful, and 451 research say 56% of apps are stateful. And the benefit of bringing things into containerization, one of those benefits is the velocity you can get. Another one is the compaction of resources. And IBM say that 75% less resources are required when you've containerized an app, well, you can get bigger savings if you bring more things into your application runtime in Kubernetes as well. So that's a high level of what a stateful and a stateless app is. Now, when Kubernetes came out, as Rashid said, right, people weren't doing stateful apps in there. There weren't persistent volume claims or anything like that. There's a good documentary on Kubernetes. If you're in this space in technology, it's really well produced, and it talks to the founders. It talks about how AWS was the competition here at the time. AWS were bigger than like the next 5 cloud providers. They were killing it, right? Still very big now. People are leveling. And what we had was the ability to do stateless apps in Kubernetes. Pokemon Go was the first app there, and they just left the state outside. And they did this because they didn't have time to solve that problem. So have a look at the Kubernetes documentary. Here, Tim is talking about it. So we can't just say they didn't want it. It's that they didn't have time to do it. So how was it done back in that scenario? Well, back in that scenario, we used to pipe it in, right? We used to pipe in the persistent file system, the shared files, the NFS, network file store, and we used to pipe in the databases. So they were attached to the system. And what we moved to then was the ability to do persistent storage and databases, and we would attach it to some storage. But to run those databases today, we've got a few options. You can run it on your own. You can also install these things with operators. So a lot of the software vendors have operators that make it easier to run these things. But ultimately, you need to persist that state in some sort of hard drive, right? SSDs, maybe it's object stores. You need something that's going to store it. And there are 2 real ways that we solve this problem. One is the way that we're used to seeing, and I'll go a bit more depth into this later in the presentation, but is to connect it, to tightly couple it to some storage. And we might have the ability to fail over to some other storage that's in a different site, say, stuff like that. But this is the connected approach, right? And you have a one-to-one mapping. Or I will switch my headset when Rashid talks. One-to-one mapping between the storage and the container, okay? And this makes for tightly coupled infrastructure. And if we have tight coupling inside of software engineering, we know that's a bad thing. And as everything is code here, this is a software engineering problem, right? So we want to move beyond that. How do we move beyond that? We use loosely coupled storage, right? So the Kubernetes native storage uses a pool of resources, and we can shuffle things around below that pool, and the application doesn't need to know about it, right? It's taken care of. So with abstraction layer. And this allows us to do a lot of good stuff for the application, a lot of good stuff for throughput and things like that, as we'll see. And it gives the operators of this system an easier time, because when things go wrong, they're no longer trying to fix things back together in the way that they were, right? It should just work. It does for our customers. So the question is to you guys, what do you think is the benefit of running state in Kubernetes? Because people are studying this. So I want you to just think for a moment about the benefits of this, because there's a report I'll show you in a moment which asked this very question to 500 executives and practitioners who are running state in Kubernetes. And they asked, what is the revenue increase that you'd put down, or the responsible revenue that is enabled by running state in Kubernetes in your organization? And a lot of companies, you know, they're not measured on public sector and things, not necessarily measured on this, right? They're measured on reliability and things like that, but using revenue as a benefit. I want you to have a think about that. And the answer is that it's between 6 and 20% of the company's revenue they put down to running state in Kubernetes. Now, this is through, you know, the people's thoughts, but wisdom of crowds is a thing, right? And getting an accurate number from many people is very likely. So even if they're half wrong, right, and it's the lower end is 6, and half of that's wrong, is 3%. 3% increase in revenue is very meaningful for most organizations. So it's certainly worth looking into this. So I'm going to talk about the ways we go about this tactically. How do we solve the problems that, that running state in Kubernetes brings up? But I want to introduce you to the way that I think about this. And in doing this presentation, I had a little go, because it's 2023, on ChatGPT, some generative AI for images. I want you to think about which of these images you thought gave me the most trouble creating them, because some were easy and some were quite difficult. So I'll share that as we go. Here's how I think about availability. Well, the first thing is I think about remedy and mitigation. And in this scene, you know, picture something like someone running across the desert. Did a good job with this one, right? What is a mitigation is something that reduces the risk of disaster. So dehydration in this case is probably most likely risk, but a remedy is something that can alleviate that problem and broader set of problems. So in this scenario, the remedy would be the helicopter. Okay, so let's give you an idea of the language we're using. So here we've got a risk of a destruction of the environment. So everything's been trashed. And because we've decided, and it's a sensible decision, to make everything as code these days, everything can also be destroyed as code. And you know, you've got to protect against that. This is a major risk factor. And I was working in my last company for a major UK retailer, one of the biggest, and someone had come in and deleted their cloud because they could just Terraform destroy this stuff, right? Get to an API and destroy this stuff. They recovered it, and then that person deleted it again, right? So this risk of a bad actor is very likely, right? It could be an inside bad actor. So you need to be able to mitigate against that risk. And there's also the ability to Terraform destroy things by accident, maybe targeting the wrong environment, for example. So backup becomes a remedy to this, so you can go back to the point where it was, and then mitigations of zero trust and limiting access is a mitigation to that. So then we've got destruction of data, which is up at the application level. And that could be through corruption of data. You know, you try to reload a database and it fails, or it could be that someone accidentally drops a table, as we see here. This takes me way back to the beginning of my career, right? I had red terminals and blue terminals and ended up writing software that made sure that what was in my clipboard wouldn't get into a production terminal, because that would be a career limiting move, right? So safeguards need to be put in place for this sort of thing, and CI/CD can help with that. But ultimately, people are working with long living systems and they might have to work directly with them. So you need some remedy to a situation where there's a big problem. And that, again, I think is backup, right? And the question of how you protect against encryption own goals, or ransomware own goals, if you will, is a challenge that Portworx doesn't help with. But certainly, as someone operating these systems, you need to think very carefully about, because I think it would be quite easy to encrypt your estate by losing a key.
Yes,
another one
I
is,
have like a personal experience, you know, of this destruction that happened. One of my colleagues was working on a customer, and we were actually doing Terraform and doing all kind of automation. So there was nothing like Portworx or something involved there, but I just wanted to give an example of destruction can happen. So it's an on-prem customer doing everything like they had VMware, Cisco, and all ACI networking and stuff like that. So they have been doing everything manually, and then we introduced Terraform to do the automation. And we were actually granted a key by the team that was like a root key to the ACI. And by just like while doing development in the dev environment, by mistake, my colleague, he called the destructive, I would say, command that actually deleted their whole network infrastructure, you know. And then they realized that we were doing work in development, but it also destroyed their production environment, you know. So the whole thing was down like for 45 minutes, but luckily they had a backup of their network infrastructure, and they were able to, you know, bring it back, you know. So definitely backups help, you know. So because things can happen when you start doing automation, and if you don't have a state, a non-state, so it was like no infrastructure, that like in all of the networking was gone, you know. So no one could access their website and nothing was happening. But it was good learning experience, you know, that okay, how come a dev environment destructive event can delete production because there was some connection. And then secondly, the learning was do not have admin or God modes key when you're doing stuff, But again, back to the point that destructive things can happen and you need to have backup to go back, But yeah, luckily they had a backup, but although they had never tested before, that was their first experience of restoring, but they managed to come back. And it was a big company, not like a small startup, Yeah. Go ahead.
Yeah.
Anthony.
No, these things happen, and we often think we don't necessarily know the probability of different things happening. So hopefully today is helpful to you to consider that, and some war stories here, right? Moving along there. So you mentioned one of those destruction of environment, but that was through potentially some complexity issues as well, which we'll come on to in a minute. But what you saw here was a dependent system, that networking failed. So really, I consider these as hardware that's under your control, or systems that are under your control or someone else's control. So if we look at sort of a public cloud, if you're going intra-public cloud region or even intra-public cloud provider, there are systems that you depend on between these systems. And here we've got a user looking very angry at his telephone, or disappointed, as the prompt was, right? That his telephone's not working, right? And this is that intermediary system that's trying to get to the thing you're working with. And you might have a local provider outage. Maybe that's one of your availability zones have an issue. Maybe it's your intra availability zone. Maybe it's your intra cloud, as I said. But ultimately, these systems are more and more complex, and the more you put in a row, the more likely failure is to happen, unless you can route that through other means to lower that probability. So that's another vector, risk vector. And then finally is this complexity issue, right? We don't know what we don't know. And as humans, optimists, in technology, we're optimists because we've decided to take on hard problems, right? We don't always understand the problems that we've not seen before. Part of that is educating yourself and seeing what's around and what people have encountered. But just know that no matter what the system, we're going to encounter complexity issues. Some of these will never be seen by us before, some of them will never have been seen before. And how we mitigate those, how do we remedy those, are examples here. So blue-green deployments, being able to roll back to a snapshot very, very quickly without having to copy things from anywhere. If you say apply a schema that didn't work, being able to test for quality, all these things come from software engineering, smoke tests and all sorts, right? These are the ways you can mitigate that risk. But ultimately, it still seems like that remedy is the backup piece. So here it is drawn out all together. And you can see how frequently backup turns up in these, and what the Portworx, which we'll get onto what Portworx can do in this area, in red for mitigations as well. So hopefully this is helpful to you. So here's how I look at these things then. I look at a foundation of recoverability as backup and restore, or in some other slides, I would say restore and backup. We don't actually care about the backup. We only really care about the restore. So if you can't get that in place, if you haven't tested it, it's not done, right? We've got to consider what done means as well. And then building on that, high availability and rollback, and we hope to show you some demos about that today, time permitting. Otherwise, you'll certainly have some links to some videos to take you through that in your own time. And then the crowning jewel up here, the thing that enables ultimate availability, is DR. But I see little point in doing a very highly available solution if you can't get back to a remedy. Okay, because what you'll have is something is destroyed on the first site and that is propagated to the second site and you've got no ability to get back. So these things build up, a bit like the way we do health, right? Eat good, fitness, right? And the other things come. Too many analogies, I'm sure. So let's look at that foundation of restore and backup. And I want to talk to you a little bit and pull Rashid in here as well about why backup on Kubernetes is challenging. So I've referred a few times to GigaOM here. GigaOM, I think, are a bit more cutting edge than Gartner in this regard. I'm sure Gartner are catching up. Kubernetes is really catching on these days. But they say, unfortunately, existing data protection tool mostly built for legacy technologies such as virtual machines, do not fit well into the container paradigm. Now, they go on and explain that in a bit more detail, but this is from that report, and you're welcome to look that up. So traditional backup looks like you've got a block store down here. It's actually quite hard to see, isn't it? But that's a block store. You've got a virtual machine that's often presenting that up. This block store might be on an array or something, and then you've got that tight coupling to a container. Now, the reason this is difficult for most backups is that they can grab the block store, that's no problem, and they can take the block store somewhere else and restore that. What they don't have is the integrations into the Kubernetes objects. And even if they've got that Kubernetes objects integration, you also have to consider that applications in microservices don't run on their own. It's not a monolithic app. One piece does one part of a bigger puzzle, which lets us solve problems with like reuse, which allows us to invest more in the quality of the applications that we create and all that good stuff. But that means to get an application level snapshot or a workload level snapshot of where the application was in a way that we could restore somewhere else, we need to know about many apps. We need to be able to back up those apps concurrently to get that consistent state. And that's a big ask when you're looking to solve the problems down here, when this could be doing something at a different time to this, and we've also got to get that namespace and everything in it all at once. And that's why just getting that backup at the storage layer is like 2 or 3 layers too far down to make a meaningful backup up here. And what does this mean? It means it's hard to restore, which means we don't test, which means when it comes to that bad day where it's broken, we didn't know until it's happened. And that's not a good place to be. Right? What you want is something that's easy to test, easy to use, and you can use it everywhere. So we created Portworx Backup for this. And Rashid will pull you in a sec to talk about your experience of Portworx Backup and competitors to this, because there are some around also. And in Portworx Backup, we can take from any source, so any Kubernetes source you start with, and we can restore to any source. So you a destination, I should say. And those backups are app-aware. If you're backing up something that doesn't natively support us taking a snapshot of the container storage, then you need to do something like quiesce the data, still the data, which allows you to get a snapshot of it. This means that you need to do a little bit of research into how your application works. So Elasticsearch, for example, has different subroutine, a different procedure you follow to, say, MS SQL, which is known to be crash consistent from what's on the disk. So you need to think about that a little bit. That problem goes away if you use our database as a service offering Portworx data services. But for this, you still need to understand a little bit. We can auto discover the clusters in public cloud. We have ransomware protection, which is another remedy from earlier, right? Because you don't want your backups to be encrypted by the time you get to them in a bad way. We can RBAC to systems, so any OICD providers, which means that you, the administrator, can enable this across your platform and then let people run it themselves. And you can set up schedules so that everyone's got that fallback. And then you can send your backups to the places that they make sense to be sent. So maybe you have a remote site in a different public cloud to your primary site. Maybe you keep one locally and you make that copy more frequently so that the restore can happen faster. All these things, right? Maybe you cycle it off to some deep storage. Now, Portworx Backup can back up to 2 places. If you spoke to me last week, it would be 1 place. The 1 place would have been S3 object stores, which enables things like object locking. But now we can also back up to NFS. So we can store on NFS, which you probably have around in your organization already, which means you can use legacy backup applications in concert with this and send them off to Iron Mountain or wherever you send the backups there. So Rashid, you've been playing with Portworx Backup. You know, this nicely solves it for your clients, but what is your experience that brings you to looking at a solution like Portworx Backup?
I think so backup has been always like, so we have been doing a lot of backup in the store with open source solution called Valero. I think we have used that a lot. And the open source originally built by Heptio, then Heptio was acquired by by VMware, right? And it's like quite well maintained solution and open source, and definitely it does solve a lot of the challenges, but then it still has few issues. And one of the key issues was regarding the multi-tenancy. So when you're building a Kubernetes-based environment and you have different tenants, and tenant could be different teams or different departments within the same organization. So it's not about you having different kind of customers sitting in the same cluster, but different departments or teams sitting in the same cluster. And there you would like to have a way to solve multi-tenancy easily, that you take a backup taken up by one cannot be restored by the other. And those kind of things are not spoiled out of the box in a solution like kind of later. Like I know they have in their roadmap to kind of look into that. But I think Portworx was one thing that really had this thing solved. And the second thing is about the user experience in terms of a UI. Because I mean, we want to do everything via GitOps, and I think that's what we love to do. But not everyone wants to do everything via GitOps. They still want to have some sort of user interface to take a look. Okay, how many backups are there out there? Okay, can I quickly do backup restore from a UI and those kind of things? And those kind of things don't exist out in much in our open source area. So I think there I also saw like Portworx has good support there, in terms of user interface. So I think those kind of two primary things, I think, were the thing that made us look into Portworx as an alternative option. So if a customer needs more hi-fi features, so I think Valero does solve the purpose. Like it can take a backup. Of course, it cannot restore a backup of Google onto Amazon. Okay, but yeah, you need to have something like Portworx or some other solution that is like that can abstract away the storage for you. But still, if you are on the same cloud and like if you can upload with some S3 bucket or storage, then it does work for you. But then if you have more needs, then you need a bit more powerful or like a different solution. So we do have like other solutions, I would say, that we have looked into, and I know customers are using it, like Kasten. We have looked into that. And there's another solution, I think it's called YS1000. I think it's another company that we have looked into, like where we have touched about these different solutions. And but definitely, I think with Portworx, we have seen some of these features that work pretty nicely. Yeah.
Excellent. Yeah, so we have a freemium offering, and this freemium offering gives you a terabyte of storage management. You still need to pay for someone for some S3 storage. That could be in your on-prem or anything like that, but this is a terabyte of management free forever, and we run the control plane for that. So it's not just we ship you some software, say there you go, you run it, we responsible for running that. So it's super easy to get started. If you have more than a terabyte you want to manage, that is for one cluster, by the way. If you have more than 1 terabyte that you want to manage, then we also do a free trial that we can get you started on. And of course, this backup product works very, very well with the rest of our suite, which I'll talk about in a moment. But it's also a standalone product, so you don't have to have Portworx installed to get started. So I'll put a link up at the end. But just know that this is super easy to get started. It'll install in 2 commands, and I think this is really a lunchtime POC. You could even try it. There's an online EULA, an agreement that you take when you go through an interface. So if you want to try moving from one cloud to another, just see how that works. Do it, right? You can do it over your lunch break, do it while you eat a sandwich, nice and easy. So that's the backup piece, right? That's your foundational remedy for possible bad things that are going to happen. Let's talk then about how we get to high availability and the ability to roll back with things like snapshots, and we'll go into that in a bit more detail. So we saw this earlier, we saw this diagram earlier. You've got that connected approach, which means when the underlying storage has a problem, you've got a problem on that node. Maybe you've got a problem with everything that's attached to it. It's not really failure domain aware, and I'll show you some more about this in a moment. But as we move to the container native storage, these problems aren't really visible to your users because the abstraction tier takes care of it. And we can also overcome limitations like the number of volumes you can attach to systems, like in AWS, for example. I think it's about 8 volumes you can attach to a system, which drives behavior as to the sizing of the instances. It might not be optimum, so we take care of that with you as well. So in Portworx Enterprise, and we've got a demo that hopefully we'll have time to roll here in a few minutes as well, we have several modules that solve these problems. So let's talk about those at a high level. We've got the store piece, which makes sure that your performance is very good, and I've got some slides on that coming up, but also that it's resilient and easy to manage. We got the migrate piece, which is sort of a streaming of your app to another destination that could be in a different cloud. It could be on a different Kubernetes distribution. So if you want to go Tanzu to Red Hat OpenShift, you can do that, AKS to EKS and so on. We can do that. And indeed, we had a customer in the Scottish government who has been on webinars with us as well, talking about this. They wanted to move an app between AWS, Azure, and on-premise, Red Hat it was. They want to be able to do that, and in the proof of concept they had, they could move their app between any of those within a minute 30, right? Which means that they can go and work in the place that makes the most sense, whether that's for performance or cost or whatever you need it to be. Maybe you want to move something out so you can work on the on-premise platform and get that fixed up or onto a new version. The secure piece is allowing you to do encryption at the cluster level or encryption at the drive level. And the drive level is important because it means you can open up multi-tenancy, like you were talking about, Rashid, where you can have many different businesses or users using a system where you need a lot of security there. You can make sure that no one could see anyone's data, even if they could get to it, because it's encrypted at that level. And then the DR piece is, we're going to cover that in a separate topic, as you've seen in my triangle, but this allows us to replicate to a separate site, separate Kubernetes cluster, and so on. And autopilot is just the removal of unnecessary work from your storage team's day or your platform team's day. So no more provision me a new drive, please requests. That's taken care of as things scale out. No more reaching into VMware and propagating the changes of adding drives and then provisioning PVCs from those drives in there. That can all be automated as well. Portworx will work with any storage. We need CSI compatible storage. We consume block and we can present NFS up and we present block up. So if you need a read write many, we can do that as well. We work with any storage, but we work particularly well with our storage provided by Pure Storage. So we can do special things in there, like provision disks directly from the arrays without having to put VMware in the middle or anything like that. And of course, this works on any Kubernetes distribution, but some very small exceptions like micro K8s, for example. Now, you guys, Rashid, I'm very interested in your experience, because the thing we get compared to most is CEPH, which I'll talk to in performance terms in a little bit. But you guys have run CEPH, right? You've run CEPH for clients, and now you know how Portworx works is part of your portfolio of things for your clients. And I wondered if you could share your experience that changed your perspective on what the go-to solution is.
Yeah, I think it's a $1 million question. Hard to answer like in a short time. But I think in terms of my experience with CEPH, I think I have run both CEPH in internal mode and external mode, like because with this current operator-based development, it works pretty nicely and it does the job, you know, and it's kind of very much integrated into, like, if you're running Red Hat OpenShift, you know, and those kind of things. It's very much integrated into that as a solution. So, and then looking at Portworx, I think it tries to solve the same problem, but in a different way. So you have less components to deploy as compared to with CEPH. So it looks like a lot of things have been abstracted away behind some simple concepts. So it looks like, yeah, the starting journeys can be quicker with Portworx, you know, like, I mean, that I can feel like as compared to CEPH. But of course, I think feature-wise, I don't think I have much deep knowledge, I would say, to compare them. Like one is better than the other. But otherwise, I think they kind of solve this challenge, the problems, I would say almost the same. But again, Portworx has some different, like backup and DR and those things are like that you can add on, so you can do. But you can still, like you can still use Ceph, but I have, I have the Portworx. I think the backup solution, I think on top shouldn't be a problem, if I'm not wrong. Yeah. So that's how I think
so we see as well some customers, they don't like running Ceph because of the complexity involved and the people involved in managing it. It takes quite a lot of management. People are expensive these days. People know what they're worth as well. So there's a cost element there. And there's also the cost element of how much resource it takes to run Ceph itself. So OpenShift, where you might run Ceph, requires separate infrastructure to run that. Portworx runs on your existing infrastructure and it adds a small amount as it's shipping around replicas of the data, but we're sort of single-digit percentages, whereas Ceph, you need to stand up some extra resources themselves. So sometimes that can pay for the licensing cost alone. So there's various things that bring it in, but we're always happy to work with the client to test this stuff out. If you want ultimate performance, we often see a real benefit in our performance as well. So here's an example of a lab. If you get in touch with me on LinkedIn or my email, details will be at the end. We take you through the more detailed run through of this, but this is how the lab was set up, comparing Ceph and Portworx there. Here's some of the stats, and Portworx comes out better on all of these metrics. The worst we come out top is by 0.5%. Might be negligible, but we're never worse, right? And when we get to the next slide, which takes you through these numbers, there's some really interesting stuff in there. But as you can see, like a meaningful difference there. Now, if we look at the numbers purely, and I think this is an easier view to take in because things are on the same sort of scale when we look at percentages, 84% faster reads, right? That's a meaningful amount. 89% better read IOPS on a sequential reads, 256 block. Look at this one, 286% PG bench scores for transactions per second, right? That is a really meaningful number. The worst we do is that 0.46%, and that's sequential writes with big block sizes, right? So that's where the storage is plugged in and it's chugging along in the same paths. So there's really no loss here, just performance improvements. And if you could cut half of your database sizing, if it's providing the storage as constraint, not compute, that's a big win, right? And this is just one of those databases. So moving on to the DR aspect, and DR is particularly interesting in our marketplace because this is a hard problem to solve. And we want to, I think when we look at synchronous DR, I'm not aware of any other solutions that solve it in the same way. Always open to learn things. Now, there are solutions that solve DR by just shipping around storage. So if we look at storage here, we've got some defined storage, maybe it's an array, and that is replicating out to a standby storage site over here. And this is what we call in pure storage an active cluster setup. And there might be a route to this one if this one fails without moving your production over and things like that. Other customers, other providers also do this, other storage providers. And this is the connected approach in practice, which can work, but it's not cloud native. And to that point, as you move this over to that second site, maybe you replicate it back, or maybe this whole site's gone down. You can make this happen. If you're doing this, you've probably got 100% waste on your second site in terms of compute resource and things like that. So it's quite expensive there as well. When we do DR, you could use your second site for something like a dev or a test environment and just kick it off when you don't need it, when it's needed for production, for example. But if we look at what GigaOM say, who do enterprise Kubernetes storage and do cloud native storage, they point to this, right? This does not mean that all these solutions offer the only or the best approach to deliver persistent storage to Kubernetes environments, right? And they suggest you look at the GigaOM radar for cloud native Kubernetes data storage. Well, that's here, right? This is that report, and you can see that of that better approach, they put Portworx as the best, the one that's most featureful, that's best set up for all market segments. So this is the table that listed all the other providers, including Red Hat, including VMware approaches and all sorts, right? They put us at the maximum applicability to all market segments, and they put us ahead. There are things we can improve on. You know, it's a moving feast, if that's a term. But we read these reports and we're constantly trying to improve as well. If you want to go and have a look at that, yeah, there's a short bit.ly link there, or you can QR code that. There's a link at the end of the presentation as well. But very well regarded and trusted by some big organizations.
Anthony, I think we just one quick, I think we're running out of time fast now. So maybe I think we should also open up for questions. So people, if you have questions, you can start shooting us. I think we're just left with 10 minutes. So let's try, you know, if we can.
Yeah.
Really awesome. I think we can spend a lot of time listening. It's going to be great. But I think to be stay on time, I think let's see.
Yeah.
So yeah, awesome. Yeah.
So the two ways we solve availability intra-site is asynchronous DR, which is allowing you to make a copy of a streaming copy of your current site over to another site, separate Kubernetes cluster with a small potential for data loss, the order of like 5 minutes. And this is because we cannot wait for acknowledgements to come back, because it would slow down your everyday operations, which would probably be worse than the less likely risk of the site going down. So we can solve asynchronous that way. And that might be region to region in public cloud, or public cloud provider to public cloud provider. This can help with that. And then the other solution is a metro DR. And we see this more on premises than we do in public cloud. You can do this in public cloud as well. The constraint is the same as Kubernetes has, that you need a 10 millisecond round trip time that is consistent. And this allows us to then replicate the storage over to the second site. And should there be an issue, we can then fail over the entire cluster for that. We do that for Royal Bank of Canada. This is the use case they wanted, and we solved that for them with their entire data centers, workloads coming up on a second site, the order of 2 minutes, right? Zero data loss between those. I'm not aware of anyone else who can do that in the marketplace. So this is our suite, Portworx sort of mapped against those things, backups there. We've got disaster recovery. Portworx Enterprise is that foundation. DR is a bolt-on to Portworx Enterprise, and backup is a standalone product. And PDS, if you want to learn more about that, there is a demo here as well. So there's the PDS and our other demos if you want to grab those as well. So I think that gives us 9 minutes for questions, and we'd be very happy to answer any questions you have now or in future.
Yeah, I think if the question pops up, you know, but I think meanwhile, if we can wait for questions, maybe we can just set up the demo. We can turn on the, you know.
Yeah. Yeah. So I've got
a. So people have any questions, they can shoot out. You know.
So let's show you about this. See, do write any questions you've got. So this is the migration and high availability demo, and we're going to show you how Portworx keeps data safe in the case of a storage failure initially. So I'm creating some data here. If you watch this online, I'll talk to you in a previous version of myself. But what I'm doing creating here is just some custom data, right? If you come to the UK, the emergency phone number is 999. I think your local one will work as well. And the 999 phone number went down about a week ago, which is worrying. So I wonder if the international emergency services worked. I don't know. So here we go. Now, a friend of mine has a dog. He called the dog Steve. I think that's a funny name for a dog, so it's been immortalized here. What we've got here on the top is our cluster. On the bottom is a cluster we will migrate to in the second half of this demo. So I'm going to pull that out of the way. What I'm going to show you here is the application. The application has 2 drives. One is a persistent volume claim. The other is an ephemeral drive. So it stores it somewhere, but should that go away, no one really cares. And the persistent volume is for a database app.
That database is a MySQL database, and it's running the back end to this pet clinic. So we have a persistent volume claim, and that is bound to the application. I'll show you a diagram in a moment because you're probably thinking the same ways as me. So we've got that volume there set up, and we can inspect that volume as well. Here's that volume. So we can see all the information that Portworx holds about this to configure it. We can see various things. So the first is that it is 8 GB in size. And the second thing is that it is up, and silence that. And then we have various statistics that this is pumping out into Prometheus as well. So you can collect these in the normal ways that you do these things. We then have a selection of nodes that this is attached to. We keep 3 replicas. We can keep 2. You could keep 1, but that's not really a replica, is it? In place there. And here's how it's looking. Right? We've got 3 failure domains there, each with some storage attached to it. And these could be spread between availability zones, for example, in public cloud. And it's currently running on node 1-2. That's where that active storage is running. So what we're going to do, we're going to cordon that node, because the sensible thing for Kubernetes to do when we kill off the application would be to redeploy it there, because the image is already on that system. And we're just going to have a look at where the pet clinic is deployed. There we go. So we've deleted the pod. Now, because TCP takes a while to time out, I've saved us 10 seconds there and not waiting for that. And the rest of this is in real time. Right. So we're having a look that this application is being brought up, and it's being brought up on a different node. And in that process, it is downloading the containers that are necessary. That is why it's taking most of the time here. If we had them pre-warmed, then this would come up. And just as I swipe right on this, you'll see that the application has come back up inconveniently. There it is, as we move this over. So it's already back up and running, and we've relaunched using our software called Stork, which is open source, onto that new application. And where is Steve the dog? Well, he still lives in Wales, in my house. Well, he doesn't, but you get the point. So that is how we do a highly available solution. And of course, this means that your applications are much, much easier to bring into cloud, because then you can trust the persistence to remain available without your engineers having to do anything. So you don't have to work out how to do, say, high availability on this, and how to do failover or Galera clustering, for example, if you can take those seconds of downtime, which you can make smaller by pre-warming the images. And I'll take care of that. Now we've got about 3 minutes left, so I imagine we can go into the migration demo. So migration is being shown here, and the migration, we're going from one site to another. Now, migration is an asynchronous process, and it's developed further to do async DR, right? So we can just continue to do migrations and then bring it up when required to do async DR. So what we have here is we've created a cluster pair. This is Kubernetes object, and we're giving this cluster pair the name of remote cluster. And in here, we've defined the namespace, the scope of this, to be kubesystem. And that means that any namespaces within kubesystem, which are all namespaces, right, can be migrated. So we can define where this goes, and we're saying it can go over to remote cluster. If you're an admin for this system, you can say maybe these go over to this cloud and these go over to that cloud, and you set that scope here. So what we're doing at the bottom half of this config file is connecting up Kubernetes to Kubernetes, and we're connecting up Portworx to Portworx. So on both sides, we're connecting those up. And you can see at the bottom there, we're connecting to one specific node. That could be any node that Portworx running on. And once we got that, we're in, and we're combined, right? We can then ship workloads between them, and we do that by the namespace. So we can see that this is up and running, right? The Stork CTL, which is that open source software, is up and running, and we're going to now define the schedule, right? The app migration over to this remote cluster. So we've got that that namespace, we're going to define pet clinic as the namespace that we're going to move. Could move any namespace we wanted. We're going to include the resources. Those are the Kubernetes resources. So if you just wanted to ship the data, you could do that, but we're including everything here, including the Kubernetes data and the block data. We're going to start the applications when it arrives. If we said false to this and continued this migration, this is a DR scenario, right? That's an async DR. So we're going to show you now that there is nothing up my sleeves on the second cluster. We're looking for pet clinic. There is none. And we're going to kick off this migration in a moment. So just watching for that pet clinic to come up. And here we go. So we're going to apply the app migration. And the migration will begin now. That's a video, so I'm sure this will work. And here's what we're doing, right? We're taking that app that's on one of the worker nodes. We're taking the Kubernetes objects and the data and sending it to an object store. That's in S3 in this scenario. You could do that on FlashBlade if you wanted. We're moving that data over to destination. We're bringing that app up. And that is what is currently happening. So there we can see it's crash loop back off. Just as the database comes up the front end, and that's the total time, right? We've moved that entire application over to the second site, 2 minutes 36, so a little bit slower than the test case we had in the Scottish government, but probably use some bigger machines there, and that's it. And Apple TV always starts up on me. I have no idea why. So I think all that's left for me to say thank you. And if
I think awesome. Really good, Anthony. It was a pleasure to have you, and really good, presentation and demo. So thank you very much, everyone. And if you have any questions, feel free to, you can drop us over the email, or and thank you very much for listening today. Yeah, thank you, Anthony. Bye for today.
Thank you. Take care.
Bye bye.
Bye.
Bye bye.